welcome students. Today we'll be discussing about the queue data structure. So what is a queue? Queue is a linear data structure following the first in first out principle. First in first out means that the elements or the items that will be inserting into a queue first would be the first ones to leave. This is against what we saw in case of a stack wherein the items that were pushed into a stack last would be the first ones to leave the stack. So that principle was known as last in first out principle. So the examples include an ATM queue or a queue at a petrol pump as is depicted in these diagrams. So on the left hand side you can see an ATM queue representation wherein a user has arrived who has arrived first at the ATM would be the first one to leave the ATM after getting the services. Similarly, for vehicles which arrived at the scene first at a petrol pump would be the first ones to leave the scene. So, what are the properties of a queue data structure? A queue is a first in first out data structure that we already discussed. Then, a queue is an ordered collection of homogeneous data, just like stacks. So, homogeneous data means that if you are declaring a queue as an integer array, that all the items that would be inserted would be integer and so on. So insertion, which is known as enqueue in this case, and deletion, which is known as dequeue in case of a queue, takes place from two ends. So insertion takes place from the rear end, while as the deletion takes place from the front end. Hence we use the service of two pointers. That means front and rear. Front would be keeping the track of the front pushed element, while as the rear would be keeping track of the rearmost element. This is again against the working of a stack wherein we have only one end and whose who's tracked by the variable top, which we used in case of stack. So how does a queue work? So we are taking an example of an array which has been implemented as queue. As we discussed in case of stack also, we have different implementations of a stack. Same for queue also. We can represent a queue using an array or a linked list. So in this lecture, we will be concentrating on the array implementation of a queue. So here also we have a array wherein we want to insert certain items from the rear end. From the rear end, enqueue takes place. From the front end, dequeue takes place. That means if we want to insert items, we will have to do that from the rear end, and the operation concerned is known as the enqueue operation, while as deletion takes place from the front end. The operation concerned is known as the dequeue. So here in this example, we have supposedly inputted 3 for the first time, followed by 4, 5, 6, 7, 8, 8. So 3 would be the first one to be traversed or to be removed if we are using a dequeue operation, followed by 4, then 5, then 6, and so on. This is synonymous to the queue we generally see at schools, or represented in this diagram, that supposedly this boy has arrived first at the queue, so he would be representing the front of the queue and would be the first one to leave against this girl, which is representing the rear end of the queue and would be the last one to be removed. So what about the operations of a queue? Operations include the enqueue operation, which adds an item to a queue, display operation, which traverses or displays the contents of a queue. Similarly, you have a dequeue operation, which removes an element from a queue. And lastly, we have a peek operation, which helps viewing the element at the front without actually removing it. So the operations of the queue, if we can can see it diagrammatically. So here we are taking the example of an array of 5 elements. It could be obviously a bigger array, but for the sake of simplicity, we'll be understanding things using this 5 value array. So for it, we would be using the services of 2 pointers as discussed already, known as the front and the rear. Both have been initialized to a value of -1. That means an invalid index for friend as well as array represents that there are no elements. So obviously the valid value for an index in case of array starts from 0. So now subsequently we are trying to insert values into this array. 5 would be inserted at the position 0. In that case, front would be 0 and rear would be 0. So 5, which is the first value to be inserted into this array, it is a special case because in case of a first item, you have the front as well as the rear represented by an index of 0. That means this 5 would be the frontmost element and this would be the rearmost element since there are no other elements currently. So we should now change when we insert 3. So in case of 3, front again would be 0, but rear would now be 1. Since you all know that in case of array, we use an index starting with 0 to represent indexes. So the index of this cell would be 0, this 1 and 2 and 3 and 4. So these front and rear basically represents the indices of these cells or these individual values or the cells of the array. So in case of 5, front would be 0, rear would be 0. In case of 3, front would be 0, rear would be 1. And in case of 6, when we try to insert 6, front would be again 0, but rear would now be 2 because the 6 was inserted at position or index 2. Same for 4, which would change rear to 3. And lastly, in case of 2, front would again remain as 0, but rear would now be 4. So we have 5 elements. Front is 0, but rear is 4. So this was the insertion or the enqueue operation diagrammatically. Similarly, if we want to display the contents of this queue using the same set of values, so 5 would be the first one to be removed, followed by 3, then 6, then 4, and then at last we'll be displaying or traversing 2. That means the first value which was inserted would be the first one to be popped out or displayed or traversed. Similarly, if we use the same array to understand the concepts of dequeue or peak, so 5 would be the first one to be removed with the help of dequeue operation. In that case, front would be 1, rear would be 4. That means rear would be remaining the same, but front has changed now from 0 to 1. As I already discussed that deletion takes place from the front end. So 5 would be replaced. The frontmost element now would be 3. If we again fire a dequeue operation onto this queue, so 3 would be displayed, but rear remaining the same, front would change to 2. Same for this exam. Now, since 5 and 3 have been removed, 6 would now be the topmost element. Say we fire a peak operation on this queue. So it would show us that 6 is the topmost element and front and rear have values of 2 and 4 respectively. That means peak operation hasn't changed or updated the pointer values. So just confirming what I was stating, if we fire another peak operation, again 6 would be displayed without doing any updations to the front and rear pointers. As discussed already, peak simply shows you the topmost element without changing anything as far as the front and rear pointers are concerned, which was not the case in case of dequeue, wherein the rear front, I should say, was changed or updated. So queue implementation, as far as writing code is concerned, we will be doing an array-based implementation and writing pseudocode for the same. So here is the first part of the implementation or the C code for the queue implementation. First, we will add some header files, library functions, and then you will basically define a max variable as 100, which would be representing the maximum capacity of the queue. Then we would be declaring a queue with the same capacity, that is max or 100. So this queue would be of the maximum capacity of 100. Similarly, we have declared R and F as front and rear pointers and initialized both of them to -1 as discussed already, and T would be a temporary variable which you would be seeing in the coming slides. So in main, you are basically presenting a menu to the user to press 1 if he wishes to do NQ or the insertion, and 2 for display, 3 for DQ, and 4 for P. So if the user wishes to insert, he will or she will press 1 or input 1, and same thing he would be doing for other operations like pressing 2 for display, 3 for DQ, and 4 for P. If he wishes to exit the program, the user is advised to press any other key. So we are scanning the value in C. So the user choice has been inputted or scanned or stored into C variable. Now we would obviously wish to see what user has inputted. That we would be doing by taking services of switch case. So in case of switch, we are switching the C variable. That means we are checking the values for C. Case 1 means if he has inserted 1, if the user has inserted or inputted 1. In that case, we will be asking for a number which is to be inserted in the queue, and we will be going to the enqueue function with that value, right? Similarly, case 2 means if the user has inputted 2, that means he wishes to display the individual items of the queue. Case 3 means he or she wishes to do a dequeue operation. Same for this 4, he wishes to do a peak operation. Default means if the user hasn't inputted any of these valid values from the menu. In that case, we will be exiting the program. So what remains is the implementation part of these 4 functions starting with enqueue. So in case of enqueue, we basically have asked for a number and we will be going to that enqueue function with that value. So let us go to that function. So void enqueue, and we are basically storing that n which was passed by the user to this n here. So before doing any insertions or enqueue operation, we must make sure that area hasn't reached the full capacity. That means we should be within limits as far as the maximum capacity of the queue is concerned. So if max here is 100, 100 minus 1 means 99. So we should be less than 99. Only when R is less than 99, in this example, the insertion would take place. So before going to the insertion part, as discussed already, since first element represents a special case, so I have written in the comments here that if f is equal to -1 and r is equal to -1, it is possible only when we start the program. That means there is no element in the queue, no value in the queue. That means it's the first item that is coming to this function in the form of n. So in that case, we will be updating the front pointer. So you must remember that this if would be true only for the first item. So for remaining subsequent items, this would never get executed. That is why f would not be updated any longer. for values 2, 3, 4, and so on. So this is a special case wherein we check that whether the item that is coming to this function as an argument is the first one to be inserted. So having checked that either true or false, that would be seen in different cases. Other than that, we'll be doing, so this is the soul of this function, this statement. So q plus plus r. So if we are arriving here for the first time, so it would be, since r would be minus 1, so plus plus r would be 0, r would be 0. So q0, 0 would be storing the element n for the first time. So if you pause this video and check what would be the value of f and r, in this case both of them would be zeros, as we just saw in the previous slide. So else means this else belongs to this if. So if the capacity has been reached, then in that case we will have an overflow condition and we would print the respective statements or the concerned output uh, for the perusal of the user. So just repeating what I said, first we would be checking whether R is within the limits and would be then able to insert that value at the q position, which would be represented by r plus plus r plus plus r. That means you will have to increment the r first, and the index which would be coming out of that would be the position or the index at which the n would be stored. In the meantime, you would be checking whether the item that has arrived, it is the first item or not. In that case, if it is the first item, then we would be doing a friend plus plus. That means we would beat the button. As I said already, that this should happen only once in our program for the first element. All right. So moving on to the display function. So again, we will check if friend is equal to minus 1 and r is equal to minus 1, means it is the case when the queue is empty. So you'll be accordingly printing the message for the user that queue is empty. Else means that either this is not true or this is not true or both are not true. Say for our example which we just saw previously, we have 5 elements. So in that case, this would not be true and the control would go to else part. So what I have done here is that I have stored the value of friend into t. Why? Because I would like to preserve the value of f. If I use this f directly in this loop, so it would change my f. So I would not be able to track the value of friend or the friendmost element later on for later on usage. So that is why I am using this temporary variable. So while t remains less than or equal to r, till then you would be printing qt. So in this example that we just saw a few slides back, so friend was 0, so t would be 0, and f rear I should say was 4. So here qt means q0. So here q0 would be printed, but while after printing, the t would be incremented to the next value, which is 1. So it would again go to the while loop. 1 is less than or equal to r, yes. So q1 would be printed while exiting, while coming out of this statement, t would get incremented again. Now t would be 2 and control would again go to while loop, because in case of while, as against the as against the if, we use or we check the condition again and again. So it would be again going to the while loop condition, so with the value of t as 2. So 2 is less than equal to r, answer is yes, or the condition turns out to be true. So q3 would be, or q2 would be printed, and then t plus plus would take the value of t to 3, and again condition would be checked 3 less than equal to 4, so it is again true, and control would accordingly proceed with other iterations. So once in a while the control will teach here with a value of 5, t as 5. So 5 is less than 4, no, equal to 4, no. So control would come out of this loop and out of this function, having printed all the values that we needed to print, right? So the last function that we will be implementing is the dequeue function. So dequeue, as we just discussed, dequeue removes the topmost element. For the time being, I would like you to concentrate on this only, leave this part. So we are basically checking if the condition that there are no elements is true, then the message empty queue would be printed, as we just saw in the previous slides also. Else would be saying the removed item is QF plus plus. Remember here that we, in case of this dequeue operation, friend is updated. So it is not like the display operation that we just saw, wherein we used a temporary variable. Here f should change because it removes the item from. So if we are suppose removing the front-most element, which would be supposedly at 0th position, so f plus plus would make f as 1, but after printing the element or removing the element at 0th position, right? So if in the case of example 5 was the front-most element, so this statement would print qf, that means q of 0, that means 5, but while exiting this instruction it would do a plus plus to f, rendering it as 1. So f would be 1. So consequently, if we again fire this dequeue operation, now q1th would be printed. That means value at first index 1. So here is the interesting part. So you will be changing this statement to item at front is equal to q of f. That means no updation to pointer, f is being done. So f, if you would print this statement say 10 times, it would print the same item, if in the meantime no other function has been called, because you are printing qf, which is what is done in case of peak. So in case of peak, what you would be doing as far as implementation is concerned, the rest remaining the same, you would be printing this q of f. No f plus plus need to add here, right? Now onto this part of the instruction or the if condition. This is to handle the scenario when say you are firing dequeue operation again and again. So you would be updating f to the next value. Then again, if you fire the same dequeue operation, you would be doing f plus plus. Say again, this dequeue operation is fired. So f plus plus would take place. So a stage would reach wherein we will have a value of f that is greater than r, because r remained the same while doing the dequeue operation. So you will have a situation wherein f would surpass the value of f. That shouldn't happen. So in that case also we'll say q has been emptied. So either the queue is empty because no element was inserted, which is handled by this part of the if condition, or all the elements have been removed using the dequeue operation or your dequeue function, which would be handled by this. Both those cases would print empty queue, right? Thank you.